This next strategy is called the four-step method. I'm not really a big fan of this, but it does work. And it does use the property of how to split the middle. Okay, and the four-step method is essentially using that cross-diagonal product. Okay, so I'm just going to highlight it here. Okay, we have our 3x squared plus 12. And the four steps involve these four steps. So we're first going to multiply the first and last term together. So really all that's doing is we are actually just multiplying that cross diagonal product. So we're getting this 36. And that 36 is then key to split up the middle term of 13. Okay, so that middle term of 13 splits into 9 and 4. And then we basically now have the split. Now, we don't show, the one thing I don't like about this method, we can't see exactly what's going on. Now it starts becoming a bit of a blur, right? There's not really any clear steps. So this case here is just this step just really involves how to split up the 13. We put the 3 x's in here just to make sure that we have the right coefficients, but if we multiply this out as is, it's going to multiply to 9x squared, which doesn't work, and 9 times 4 doesn't give us the original 12 that we started with here. So what we need to then do is we take the factors of a, the leading coefficient a, and divide by the factors of a. So a is 3, so we divide by 3 and 1. Well, this divides evenly by 3, this divides evenly by 1, so we end up with x plus 3, 3x plus 4. Okay, so this I'm not really going to go too much into this four-step method because, like I said, it's not really the best way because we can't see what's going on in here. Okay, so what actually really happened was we just split the middle. That's really the key, and that's really what I want you to take out of this four-step method is that 36 allows us to split the 13 into 9x and 4x. Okay, that's where the 9 and 4 comes. Now we have to still factor by taking out the common factors to be able to get the length and width. So we take a common factor of 3 here, x here, 3 here, and 4 here. And there's our factored form of 3x plus 4 times x plus 3. Okay, so I'm not going to go too much into this four-step method, but if you follow these 4 steps, it does work, and it is based on this diagonal product. The last strategy I'm going to show you here is really just the same as what we did before. It's just we're going to use this, basically we're going to use the cross-diagonal product of 36, and we're going to then use that 36 to find our split for the 13x. So we end up with 3x squared here, 12 here, and our cross-diagonal product is 36x squared. It shows up as first times last. And then that allows us to then split up the 13 into 9 times 4. Gives us the 36. There it is, 3x plus 4, x plus 3. And again, it doesn't really matter which is our length and width. Okay, I can switch, if I switch these, it doesn't make any difference except the horizontal and the vertical just switch. So let's give this a shot here. We're going to have our 4x squared minus 3. We're going to do step 1, negative 12x squared, and that allows us to split the 11. Okay, well, what multiplies to negative 12? So one's got to be negative, one positive, and have a difference of 11. Well, that's got to be negative 12 and positive 1. Oh, sorry, positive 12 and negative 1. Okay, so once we have the split of this area, we can just factor this. Greatest common factor is 4. We have a negative 1 factor here, x, and the common factor here is going to be 3. And it multiplies, 4x squared, 12x, negative 1 times 3 is negative 3. So there's our factored form, and it's nice and efficient. Okay, we're not doing a lot of guessing and testing. Okay, although we may have to rely on that if we forget how to do this, and that's okay, but this strategy is fairly efficient, and we want to become efficient at factoring because you're going to end up doing a lot of factoring in grade 11, 12, calculus, etc.